Alright, I'm testing the new setup. I got my other camera over here taking a video of this multimeter. Here's I'm pointing to it. Okay. Now, you see on the multimeter, it's connected where it's supposed to conduct current. This is a 20 amp setting here. This thing. And it is connected to the 20 amp port. So, when I rotate this, if the circuit is closed, this thing should run. Okay, we see that it's not connected. So, okay. Just have to change this little thing here. Now, I don't got all my batteries charged yet. And I'm only using some of the batteries, which half of them are discharged. Now, you see the shaft? I hold this now, like, let's say I put 3 pounds of force. Now it's slowing down. If I let go, it speeds up a little bit, slowly. Now, I'm using a tripod now because I've received so many complaints about how people can't see very clear of what the motor is doing. Now, I have this drawer here, and this is where I save my strips. Now, unfortunately with a tripod, I can't adjust the thing all the time, so I'll just have to put it inside the view. Now, this is a low setting because what I have is a lower voltage, probably around, say, 80 volts or something. Now, I have to get used to this because the tripod's in the way, but I can still demonstrate this thing while showing the current values and stuff. Now, you can see here that this current is going from 0.00 to 0.03 to 0.04. Why? Because why is it that low? Because I have this much resistance, which I'm going to measure, and the voltage is lower. Now, for measuring the voltage, I keep the leads in series with the batteries. So, the problem here is, cramp this. Not much room. Hit me in the elbow. Sucks. There we go. Now, before I connect it, there we go. Now, you should see the multimeter. It should eventually give a reading. If I press this, there we go. Now does it give a reading? Okay. Now it says 111 point something volts. Now I could show it on a higher setting where it won't show the decimal point. Okay. So, for some reason, for a more accurate reading, I can just take this lead over here and connect it. It says 116 right on the spot. Alright, now I put this back over here. Now, get this red wire, and I want to measure the resistance. Okay? Now, that's the setting I want. Now I stick this thing inside the carbon brush, and, well, is it going to measure resistance or what? There we go. I have to tighten this thing again. Now, give it some time, and it reads 443 ohms. So we have 4 times the ohms as we do the volts. So volts divided by ohms, we should get 1/4 of an amp maximum. Okay? Now, let's see if we put this back over here. Before we do that, we switch it to the voltage thing, and we connect it over here. Now we're going to stall the thing. See, if we stall it while the current is rising, then it can rise to its full value. if it's running, it can't. So I take this out, then I put this here. Okay, now we're going to install it in place. What is it going to show? First of all, we put this thing tight. It has to be tight. Okay, now put it just here. Okay. The wrong setting anyway. Okay, it was probably not connected. Great. Oh, I know why. It's in the wrong one. I couldn't even see it from this angle. Now let's do it. Installed it. It says, okay, is it the right setting or no? Okay. Now let's do it. Okay. It shows 0.1, okay, 0.1 watt amps on this setting. Okay. And with that, with a resistance of 444 ohms, what do you think the voltage is in full load when I'm installing it? Now, when I put this here and the voltage ohm jack, it shows this many volts. But 444 ohms times 0.1 amps equals 44.4 volts. Therefore, the voltage falls down under load, obvious, but is it strange enough that it will go from 104 volts, let's say, down to 44 volts under load? Okay? So what is the power then? Do we take the voltage according to we charge it times the current, or do we take the voltage under load and multiply it by the current? Now, if we're going to be conservative about the input power, we would be better off to overestimate it than to underestimate it. So we would take the voltage according to this, and then we multiply it by the current while running. Now, because the current is not sinusoidal, it's on and off, we're going to overestimate the current. And we're also going to overestimate the voltage because under load it's only 44 volts. Now we can try this again, see if we can get that current to get higher under load. Okay, now install this. Okay, we got this a little bit different now. Different approach. Now, okay, you see how the current fell even as I held it down. That's because charge is stored in these charge storing things, batteries, because just like a capacitor, if you draw from a capacitor, you draw quick, you're not going to have the voltage last as long when you have a large load to draw current. So, alright? You gotta have to get used to this setup because it's just awkward, but maybe you can see it better. Alright?